Question 4a part 3 says, using the fact that z, now we know z is minus root 3 plus I, so using the fact that z is one of the roots, or otherwise find the other roots of z to the power 4. So that means if I look at this, if they want me to find the roots of z to the power 4, I'm aware that there's 4 roots. So, you know, don't get distracted from this or confused because they have z's. If this was an x squared equals 81, you know, you'd be able to find the roots of that equation knowing that, okay, I'm going to get the square root of both sides, or, you know, I can use the difference of two squares. I'd end up with x is plus or minus 9. So I'm aware that I'm looking for 4 roots, and I can either use the fact that I know one of them, and they said, or otherwise find the other 3 roots. So I'm going to go with the or otherwise first, just to start off with. So I know that from part 2, I'm after figuring out that z to the power 4 is equal to minus 8 root 3 times I. And I'm going to use this idea here. I'm going to get the 4th root of both sides. So I end up with z is equal to minus 8 root 3i, and to get the 4th root of that is the same as to put it to the power of a quarter. Now, I can work with this now and know that if I have an awkward power, I'm not just going to go into polar form, I'm going to go into general polar form. So I can use my calculator or I can use my trigonometry to go into general polar form. So I can't put it in exactly, but I can put in the minus 8 and the comma and minus 8 root 3. And I'll end up with 16, and theta is minus 120 degrees. Now I can obviously work with that. Minus 120 degrees, so that's 16 is the modulus, and minus 120 is the same as 360, go back 120, so that's 360 minus 120, we have 240. So that's the cos of 240 degrees plus I sine 240 degrees. You know, if that was my answer, I'd probably give it in polar form, but because I'm using it to work out the question, I'm not going to give it in polar form. In radians, sorry. Now, that is just polar form. We need to use general polar form. And again, if it was in radians, it'd be 2 pi n, but it's 360 n. And that's all to the power of a quarter. The reason that I'm in general polar form is because I need 4 solutions. Okay, I need one of which I already have, but I need my 4 solutions. So this allows me to get various solutions. So I'm going to go back to the fact now that I'm going to apply de Moivre's theorem in a few seconds. But firstly, I'm going to use my rules of indices to put each one to the power of a quarter. So 16 to the power of a quarter plus 2. And then de Moivre's theorem says that I can bring the power down in front. So it's a quarter times 240. Which is 60. Now, I can leave the quarter outside it if I want. But just remember, if I'm multiplying in, it's 60 and then plus 90n plus I sine a quarter times 240 plus 360. And again, if we multiply that in, it's going to be the 60 plus 90n. So I'm going to choose to let n equal to 0, n equal to 1, n equal to 2, n equal to 3, and work this out. So if I choose n is 0, and I can just throw that into the calculator. 240 plus 360 times 0 is just 240. A quarter of 240 is 60. That's 2 times the cos of 60 is 1. So one solution is 1 plus 2 times the sine of 60 is root 3 times I. So that is one solution. If I let n equal to 1, that's 2 times the cos of a quarter, 240 plus 360 times 1, plus I sine a quarter, 240 plus 360 times 1. So that is 240 plus 360 at 600 divided by, or multiplied by a quarter, is 150. So that's 2 times the cos of 150 is minus root 3, and 2 times the sine of 150 is 1. That's actually the one that I had. Okay, that's one of the solutions that I had. So I'm just going to go for n equal to 2. And I'm going to throw that in. So 240 plus 720 is 960. I have 960 multiplied by a quarter is 240. So that is 2 times the cos of 240 is minus 1. And 2 times the sine of 240 is minus root 3 times I. Here's another solution. And if I go again and throw in n is 3, I'll end up with another solution, which is root 3 minus I. And they're my 4 solutions, one of which I already had. So that's the otherwise way of doing it. A little bit long, but still nothing wrong with that. There's a little bit of a shorter way to do it. Knowing that one of your solutions was minus root 3 plus I. If you know there's 4 solutions, well, you know that they're actually 90 degrees apart. And so that's root 3 minus I. How do you rotate by 90 degrees? That's just by multiplying by I. So if you get this and multiply by I, you'll get this one here. If you get this and multiply by I, you'll get this one here, which is the root 3 minus I. And if you multiply by I, you'll get back to this one here, which is 1 plus root 3I. And again, if you multiply by I, you'll be back to the start, which is the one that you already knew. So there is a slightly faster way to do it, but it requires that you understand that if there's 4 solutions, then they'd be rotating by 90 degrees. If there's 3 solutions, you'd rotate by 120 degrees. So that's the second way to do it.